Hey everybody, let's go ahead and talk about how you can find the physical properties of the chemicals that we're going to be using throughout OrgoLab. So I think this is personally the easiest way of going about doing so. So go ahead and open up ChemDraw, and if you look here you can see that I'm actually running ChemDraw 18, which I think is more annoying to use than ChemDraw 16. So if you can get ChemDraw 16, I highly recommend doing that instead. So let's go ahead and start out by drawing the compounds that we're going to be using throughout the lab that we're looking up the compounds for. In this case, I'm going to model it after the Diels-Alder reaction that we did in the first day of lab. And if you're wondering how I'm doing this so fast, there's an absolute legend on YouTube named ChemDraw Wizard. He's got about 4 or 5 tutorials on how to use ChemDraw, but the first two are really the only relevant ones to doing this efficiently. So I highly recommend taking a look at them, and he'll set you up with all the hotkeys to do this fast. So after drawing them out, space them out a little bit, you can highlight or you can select all of the compounds, and you can click Structure, Convert Structure to Name. And if we try that one more time, then it should work, and there we go. So we have the names of all of the compounds that we want to look up. And for some reason on ChemDraw 18, after converting the structure to the name, it numbers the carbons. I'm not sure why or how to turn it off, although admittedly I haven't looked very hard. But in ChemDraw 16, that is not on by default. So anyway, once you get the names of the compounds, it's as easy as copying, pasting it into Google with the word sigma next to it. What sigma is sigma Aldrich. They're a very popular chemical supplier. And once you click on the link, you can see here is the compound that we're interested in. And already you can see some relevant information, such as the CAS number, as well as the molecular weight. And if you scroll down, you'll get to this table called Properties. And here are going to be the other relevant properties, such as boiling point, as well as melting point and density. So which of these properties do we really care about? We know that this compound, this diene, is a liquid at room temperature because it melts all the way at -76. So the relevant property of this is going to be its boiling point as well as its density. Right at the end of the lab, if we want to rotovap this away, if we know that it boils at around 70 degrees, then we can reasonably assume that we will be able to get rid of this by rotovap. So there we go. Now we already have the physical properties for one of the chemicals. Now let's look up the other one. Same thing, look it up with the word sigma next to it, and you'll see here it is, dimethyl fumarate, sigma Aldrich. Go ahead and click on that. And same thing, although sometimes you see that the structure that they have on here looks a little bit funny. I'm not exactly sure why, but this is the right thing. And so once again, you have your CAS number, you have your molecular weight, and if you scroll down, you have your properties, boiling point, melting point. And unlike the last compound, this one is a solid at room temperature, which we know because it melts at around 100 degrees. So the relevant physical property for this thing would be its its melting point, right? We're never going to get this thing to 200 degrees Celsius in this lab to boil it, but it would be helpful to know that this thing melts at around 100 degrees, so you at least know it's a solid at room temperature. And notably, there's no density, and this is because you usually don't need the density of a solid to measure it out. Usually, with a solid, you're just going to weigh it out by mass. You're never going to do anything with its volume. So the relevant physical property here is the fact that it melts at around 100 degrees Celsius, as well as its molecular weight. So there we go. Now we have the physical properties of two of the compounds that we're interested in. And let's go ahead and try to find this third one. And so sometimes you look it up with sigma, and some of these compounds with these very convoluted names, you'll see that I already tried clicking on a few of these. If you click on the sigma link, you'll see that this is not the compound that we're interested in. And if you go back and scroll down, you'll see that there are actually no other sigma links to click on. So when this is the case, it could be the fact that this name is just not what's being recognized by sigma, whatever this is that ChemDraw spits out. although you can reasonably assume that Sigma would have this name, or it would at least be able to recognize it. But if you're unsure, then you could also look up Sigma substructure search. And so when you do this is basically Sigma's native little ChemDraw. Here you can just draw out the compound that we're interested in. And this is a little bit less intuitive than with ChemDraw. It's a little more annoying, but that's okay. So if you draw it out, you'll see that there are actually a few different ways on how to look this up, namely substructure search, which means that it'll look for this as the core of the compound, or this will be somewhere in there with maybe some things hanging off of the carbons, maybe ethyl groups here instead of methyl groups. Or you could search it up as the exact structure, which means that this is the only thing that it will be looking for. And in this case, let's just look up substructure, see if we can get any hits on this. And so it'll search, and it'll come back with nothing. So this is because Sigma just doesn't sell this compound, so it doesn't have any information on it. And when you run into this problem, where you can't find the chemical on Sigma, then the next place to look is going to be SciFinder. So how do you do that? You can do that straight from ChemDraw. On ChemDraw 16, if you go to View, Other Toolbars, down here, there will be a SciFinder toolbar. But for some reason in ChemDraw 18, I don't see this. I can't imagine they would have downgraded that. Maybe it's hiding in one of the other menus, but I can't find it. Anyway, regardless, you can highlight the molecule. You can click Search, and you can click Search SciFinder. And so just like with Sigma, you can see that you can search it up by substructure, and you can search it up by exact structure. These mean the same things as in Sigma. Or if you want to see some reaction schemes, you can look this thing up as a product to see how it's made. Or if you're interested in what people use it, what people do with it, using it as a starting material, you can click Selected Structures or Reactants to find that. So in this case, we want just the exact structure. So let's go ahead and look it up. Go ahead and sign in. And it'll process. You maybe have to sign in again here. Do it. Great, so then it'll try to retrieve this answer set of what you're looking for, and it'll come back with a bunch of hits. You can see that it's all basically the same thing, but deuterated or cis versus trans. In this case, this is the one that we want, the trans isomer. And if you look right under here, you could see key physical properties. And if you go ahead and click on that, you'll see molecular weight, you'll see melting point, boiling point, density, and you know that this melting point is correct because it says experimental here, as opposed to predicted like it has for boiling point and density. What experimental means is that someone actually went and measured the melting point of this thing. Although the predicted values aren't always very inaccurate, although you can see here that this boiling point is within 40 degrees, which isn't the best. But anyway, we know that this thing is a solid at room temperature because it melts at around 50 degrees. And so here the relevant bit of physical information is going to be this melting point. Right at the end of the lab, we synthesize this thing and we want to check its purity by melting point. So it helps a lot to have this on hand in your pre-lab. So now we have the physical properties of all three things that we're looking for this lab specifically, and you could obviously do this for every other lab moving forward. And just another quick little thing, you can in ChemDraw get some properties as well, although you can't get boiling point, melting point, all that fun stuff. You can highlight the compound, you can go to View, you can go Show Analysis Window. And this will give you molecular weight, formula. And if you're going to use this to report the molecular weight, make sure you do report the molecular weight instead of the exact mass. And you can play around with how many decimal points, although you don't really need more than 2. And you could just do the same for all of them. You could highlight it, you could see everything changes. You could highlight this, you can see everything changes. So once again, to do this whole process, you'll boot up ChemDraw, you'll draw out your compounds, you'll highlight them, and go Structure, convert structure to name all of them. Then you'll copy and paste the name into Sigma. Sigma will hopefully just have the compound that you're looking for, and from there you can get molecular weight, you can get boiling point, melting point, whatever you want. If Sigma Aldrich does not have the compound that you're looking for, you can instead, highlight it from ChemDraw, go to search SciFinder, and search it up on SciFinder. And if you're not convinced that Sigma just doesn't recognize the name, then you can always go ahead and just look it up in the substructure search. You can draw it out and see if it does recognize it. And that's basically it. I think that's the easiest way to get all of the physical properties of the chemicals moving forward in OrgoLab. So, I hope this helped.